Hello amigos, this question is modulus terms linked with the quadratic equation. Observe that he is asking to count us only what are the number of real roots of this equation. He is not asking us to find the roots, okay? But the modulus terms makes it complicated. So let us try to understand how to split this modulus terms. First modulus term I have is mod x minus 2. Second modulus term I have is mod x minus 3. How can we understand these modulus terms? When we have more than one modulus terms, always divide them into different regions. What I mean by that is, first of all, make the first term as 0. Now what you got is x equal to 2. Make second term as 0. What you got is x is equal to 3. Since we have two different modulus terms, we need to divide the x real line into different regions. Sir, how can I do that, sir? Now this is number line, leftmost is minus infinity, rightmost is infinity. Now mark x equal to 2 and x equal to 3 approximately. So this would be x equal to 2 and let us say this is x equal to 3. Now it is divided into three regions. We can clearly see this is the first region, this is the second region, and this is third region. What is first region? First region is from minus infinity to 2. I can clearly see this is minus infinity to 2 is the first region, which means that in this region x belongs to minus infinity to 2. Now second region is 2 to 3. So in this region x belongs to closed bracket 2 to 3. You may be asking, sir, 2 is part of region 1 also, region 2 also. Why you are giving open bracket for region 1 and open bracket closed bracket for region 2? Actually you can give closed bracket to either region 1 or region 2. My habit is to give right side as a closed bracket. It is basically, the entire splitting is basically based on one fact that if I have mod dabba, then it is plus dabba when dabba is greater than or equal to 0. What do you mean by greater than or equal to 0? It is right side to the 0. How are you getting the 0? When you put this term as 0, you will get dabba equal to 0. It will be what? Minus dabba when dabba is less than 0. What do you mean by dabba less than 0? It is negative side of 0. What is 0? You got it by putting the term as 0. So based on this we are splitting this. Now come to region 3. How is the region 3? Region 3 is from 3 to infinity. So that is x belongs to closed bracket as it is right side 3 to infinity. Now we have divided it into three different regions. If there are three terms, we will get four different regions. Now let us understand how are these two modulus terms are behaving in three different regions. First is mod x minus 2. Second one is mod x minus 3. It is simple. How to understand modulus term is, if it is left side, you keep it as minus. If it is right side, we will keep it as plus. Now the first region is this lines intersecting region. This is first region. In this region, now take mod x minus 2. Mod x, what is the number related to mod x minus 2? It is x equal to 2. For x is equal to 2, region 1 is on the left side. So if it is on the left side, it is minus of x minus 2. What is the number related to mod x minus 3? X equal to 3. Region 1 is towards left side of x equal to 3. For x is equal to 3, region 1 is towards left. So if it is left, minus of x minus 3. Region 1 splitting is over. 1 splitting is over. Now come to region 2. Marking region 2 as with dots. I am marking region 2 with dots. In the dotted region, okay. For x is equal to 2, the dotted region is towards the right. So mark it as plus x minus 2. For x is equal to 3, the dotted region is towards left. So mark it as minus of x minus 3. Now the third region I am marking it as crosses. For x is equal to 2, the crosses is on the right side, so plus x minus 2. For x is equal to 3, the crosses are also on right side, so which is plus x minus 3. Now the division of the modulus terms are over. Once the division of the modulus terms are over, now it is very simple for us to solve the original equation. What is the original equation? X into mod x minus 2 plus 3 mod x minus 3 plus 1 is equal to original equation under 3 regions or 3 cases. That is case 1, that is x. Case 1, that is x belongs to minus infinity to 2. Case 2, that is x belongs to closed interval 2 to 3. Case 3, that is x belongs to closed interval 3 to infinity. Okay. Now what is the original equation? Tell me. The original equation is x into mod x minus 2 plus 3 times of mod x minus 3 is equal to 0. How can we write the modulus term? Now in case 1, mod x minus 2, I can clearly see that it can be written as minus of x minus 2. So x into minus of x minus 2 plus 3 times of mod x minus 3 can be written as minus of x minus 3. So minus of x minus 3 plus 1 is equal to 0. So that is minus x square plus 2x minus 3x plus 9 plus 1 is equal to 0. If you solve it, minus x square minus x plus 10 is equal to 0, which is x square plus x minus 10 is equal to 0. To understand if we have we can have the real roots or not, first find the discriminant. Discriminant is b square, that is 1 square minus 4 into 1 into minus 10, which is 41. Yes, 41 is greater than 0. Everybody should understand that this is where we can go wrong. That is, once we found out discriminant equal to 41, that is greater than 0. Sir, in the region 1, I am getting 2 real roots, sir. That is where we go wrong, guys. Amigos, why we will go wrong is here. Yes, we are getting 2 real roots for this equation, but are these roots satisfying my region 1? What is my region 1? Whatever the root or whatever the x value I got, it should be between minus infinity to 2. Then only that is a valid root. So to understand if it is a valid root, first find the roots and find if it is in the correct x values of minus infinity to 2. Now the roots are x is equal to minus b minus 1 plus or minus square root of b square minus 4ac discriminant by 2. I don't know what is the value of root 41, so I will approximate. Root 41 is between root 36 and root 49. Root 36 is 6, root 49 is 7, so somewhere between 6 to 7. So I am taking 6.4 approximately. So that would be minus 1 plus or minus 6.4 by 2. The first root is minus 1 plus 6.4 by 2. Second root is minus 1 minus 6.4 by 2. The first root is 6.4 minus 1 by 2, which is 5.4 by 2, which is 5.4 by 2, which is 2.7. The second root is minus 7.4 by 2, which is minus 3.7. Now check if the two roots 2.7 and minus 3.7 are valid roots or not. Is your 2.7 in the region which is between minus infinity to 2? 2.7 is more than 2, but my x is less than 2. So whatever the root I got, 2.7 is invalid root, because 2.7 is more than 2. It should be it should be only less than 2. What about minus 3.7? Minus 3.7 is, yes, it is less than 2. Yes, it is a valid root. Yes, minus 3.7 is in the region 1 only, that is minus infinity to 2. Yes, that is a valid root. What is the root corresponding to minus 3.7, guys? Which is minus 1 minus root 41 by 2. Even though he is not asking us to find the roots, I am just writing. So that is the root corresponding to it is minus 1 minus root 41 by 2. This is the one valid root I got. Understand that case 1 has one valid and correct real root. Now come to case 2. What about case 2? Our original equation is x into, this is the our original equation. So how mod x minus 2, I should replace it with x minus 2. So that is x into x minus 2 plus 3 times of this mod x minus 3 should be replaced with minus of x minus 3. So minus of x minus 3 plus 1 is equal to 0. Yes. So that is x into x square minus 2x minus 3x plus 9 plus 1 is equal to 0. So x square minus 5x plus 10 is equal to 0. Now let's find out the discriminant. Discriminant is equal to b square, which is minus 5 whole square minus 4 into 1 into 10. That is 25 minus 40. 25 minus 40 is minus 50. So minus, it is less than 0. When discriminant is less than 0, will you get any real roots? No, not at all. So in the region 2, we are not getting any real roots. That is, we are getting 0 real roots. The count here in the region 2 is 0. Now come to case 3. So case 3, again solve the original equation, x into mod of x 0. Yes, this is original equation. Now what about mod x minus 2? This mod x minus 2 should be replaced by plus x minus 2 in region 3. So that is x into x minus 2 plus 3 times of this mod x minus 3 should be replaced by plus x minus 3 in region 3. That is x minus 3 plus 1 equal to 0. So that is x into x square minus 2x plus 3x minus 9 plus 1 is equal to 0. So that is x square plus x minus 8 is equal to 0. What is the discriminant? It equal to b square 1 whole square 1 minus 4 into a is 1, a is 1 is minus 8. So 32, which is 33, which is greater than 0. Yes, but it can have real roots, but are they valid roots? When we can confirm that they are valid roots? When the root is between 3 to infinity, that is greater than 3. So what are the roots? Find the roots. X equal to minus b minus 1 plus or minus square root of b square minus 4ac, that is discriminant 33 by 2. 2 into 1, that is 2. What is approximate value of root 33? Root 33 is root 25 root 36. So it is near to root 36, which is 6. So I will take 5.8. So that is approximately minus 1 plus or minus 5.8 divided by 2. So the first root would be minus 1 plus 5.8 by 2. Second root would be minus 1 minus 5.8 by 2. So 5.8 minus 1 by 2, which is 4.8 by 2, which is 2.4. This is minus 6.8 by 2. Minus 6.8 by 2 means minus 3.4. Is your 2.4 a valid root? No, it is less than 3. But x, the root should be more than 3, 3 to infinity. 2.4 is not a valid root. Is minus 3.4 a valid root? No, because minus 3.4 is less than 3, but the root should be x belongs to 3 to infinity. So minus 3.4 is also not a valid root. So how many real roots we got in region 3? 0 real roots. So the equation combinedly will have 1 plus 0 plus 0 real roots. That is, the equation combinedly will have 1 plus 0 plus 0 real roots. So how many total real roots? Only 1 real root. That is, option D is correct. What should I understand from this question? The question teaches us, when we have more than one modulus terms, how to split the into region and how to write the x values for the corresponding regions. Not only that, when we solve the equation under different types of region, always make sure that whatever the root you got under a certain region, is it a valid root or not? How can we check that it is a valid root or not? Whatever the root we got, if it is in the proper x values of the given region, then that is a valid root. So make sure that whatever the root you got under a certain region, valid or not. Then finally count the number of real roots. Even though in the question it is not asked, I'm just saying this equation, that is a big equation of x into 1 equal to 0, has only one real root that we got from region 1, that is -1 minus root 41 by 2. This is the only real root which this equation has. Thank you.